All right, can we see the slides? All right, is there anything
Yes. Yeah, we can
obstructing
see it.
view of the slides at the moment?
Just the slides.
Awesome. Okay. Hi, everyone. Welcome to my talk on migrating from a monolith to microservices, which seems to be something that's being tackled in a lot of organizations right now. I've spoken to a few different companies about it, so I figured that I'd share some of my learnings. About me, my name is Huey Coles. I am a lead developer at a company called Index Exchange. We are one of the largest independent ad exchanges globally. Most of my career has been as a full stack .NET developer, but the last couple of positions I've taken have been Python and Golang. So trying to try something different. .NET's fun, but it's nice to learn new things. I have done a couple of talks previously for DevHub. Those talks include RESTful service design and an introduction to serverless architectures. All right, so today I've decided to organize this talk as a three-part talk, talking about what these terms mean, why we would want to move between these different architectures, and then how we would go about it. So what? I'm going to start off with a couple of definitions just to make sure that we're all speaking the same language. Firstly, coupling. Coupling is the tendency of a component to change when something else changes, right? So it could be as simple as when you call a function or a method. When that method changes and the signature of it changes, the caller has to change code in order to call it, okay? Coupling is a natural aspect of software development. It's necessary in order for things to collaborate. But at the same time, there are different types of coupling, and there are certain effects of coupling that you want to try to reduce. And we'll talk about that a bit later. And then we've got cohesion. Cohesion is basically things that play together, stay together. So if you've got two or more objects that rely on each other and they relate to each other in a business domain, and more importantly, they tend to change together, it's best to keep them in a single unit or a closely grouped set of units. And I can talk about that a bit later, but the main reason is that you don't want a small change to propagate through your system. You want to be able to change and deploy as small a unit as possible, just to make your life easier. All right, a monolith. Monolith literally means indivisible, but for our purposes, what we mean is something that is necessarily deployed and moved as a unit, right? So it can still be different pieces. Like you can have an architecture where there are different services, but if they are so tightly coupled that you can't make a change and deploy one without deploying multiple services, this is still considered a monolith. It's a specific type of monolith called a distributed monolith. So the standard monolith will typically run in a single process, but as I just described, that's not necessary. So here's an example of a three-tier architecture monolithic application. So you've got your presentation layer, which is your UI, usually done in, for a web app, will be done in HTML, CSS, all that good stuff. You've got your logic layer, which tends to be done on the back end on the server. And then you've got your database, which is also usually deployed on a different server. And this in itself is actually a distributed system of sorts, in the sense that the database tends to not be on the same box as the front end and the back end. So this is the base that we're going to work on when we're talking about monoliths. Okay, Service-oriented architecture is something that was very popular 5-10 years ago, and it's the first step towards breaking things down into related parts. So it's a software architecture where we're basically splitting the functionality into different processes, as opposed to microservices. This is basically a middle ground. So it's not one application like a monolith, but it's not many small applications. It's something where you can group things together in large sections based on business divisions. Really depends on your use case. They're usually between 3 and 10. Those aren't hard fixed numbers, but you generally don't see one with only 2 services, and any more than 10 and you're getting into microservices territory. And this is an example of a service-oriented architecture. So you've got user management, you've got logistics separately, you've got billing and invoicing. You can have different dependencies on your data sources. So in this case, the white arrows are representative of when a service relies on its own data store, which is important. You generally want to keep it this way. The red arrows represent when you are crossing the stream, so to speak, and relying directly on the database of another service. This is not atypical, but it's something to be avoided because it does couple how your services to the underlying representation of other services, which is kind of defeating the purpose of breaking things down into services. Okay, microservices, the reason we're here. It's the next evolution. So basically, we started with very large applications. We started breaking them down into smaller business units that represent large portions of our domain. And what that allowed us to do was to deploy and change things independently to reduce coupling, essentially. Microservices is the next evolution. We're talking about smaller services with just a few endpoints, a small surface area that will allow you to do one very specific thing very well. And what that does is it allows you to focus the knowledge and to really reduce coupling to the point where these things can be deployed and modified independently, which is very important for microservices. They're also very large, right? So we're not talking about a couple of services. Microservices, depending on the size of your organization and the granularity with which you want to do this, we're talking dozens, hundreds. Even if you're talking Netflix or Amazon scale, you're talking about thousands of different services. So this is a small microservices architecture, but it gives you a sense of the granularity that you can go with. For instance, we've got different services for SMS versus email, right? They don't necessarily, they could be grouped together, but in a microservices architecture, you tend to want to be more granular because something that changes in the SMS service shouldn't really require us to change or redeploy our email service. You also notice that some of these microservices have their own UIs, whereas other ones, such as our email, our SMS, our auth, they don't require UIs, right? So they're just a backend floating in the ether. So the question is, now that we have a common understanding of what a monolith is and what a microservices architecture is, the question is why? Why would we want to do this? Let's talk about some shortcomings of a monolithic architecture. Strong coupling. So when you make a change to one small part of this application, most or all of the application needs to be deployed. Okay, it needs to be retested as a whole. and that can open up more risk, right? It has to be deployed and scaled as a unit. So if you find that your billing service or the billing portion of your application gets a lot more usage than the rest, you will still have to deploy multiple instances of the entire application. And this goes if you have a monolithic database structure where the entire application uses the same database, you're going to run into the same issue where you have to replicate the entire database rather than just the portions that are used more. And this can cost more money. It can lead to an inefficient use of your resources. Single point of failure. When a monolith goes down, it goes down hard. There's generally no way to limp along with reduced functionality. The entire application becomes unavailable. It's also a single code base. So when you're working within the code for a monolith, you've got a lot of details that you may not be interested in, and they are intermingled with the code that you actually care about. Code bases can get quite large if you're working on a non-distributed version control system like Subversion. Then what you end up getting is a lot of conflicts with checkouts and things like that. Your clones are much larger than they need to be. A single code base can be onerous at times. Benefits of microservices. It allows you to move fast. Okay, so if you've got a small service that has a very specific use case and a very specific job, it allows you to iterate on that very quickly. And since you can deploy independently, you don't have to wait for one of these large releases. You can release multiple times a day. It's very low risk, especially since if you break something, you're not breaking the entire application. In many cases, you're actually, you are hurting your service, but it's also easier to roll back. Small deployments mean lower risk. I think we've all been in situations where, we set that release date and there's a large amount of testing that goes into it beforehand. And people are very worried about the application, the deployment not going well, the application going down, things like that. Smaller pieces being deployed many times a day, it really alleviates that concern. You don't have to make major releases. It's just generally a less risky way to release software. Strong cohesion and localized change. So what that means is that when you change something in your bills service, only the bills have to change, right? There's nothing else that relies on it. And as such, we can deploy these things and move these things around as we need. And there's no chance of a change in the bill service breaking the shipping service, which anyone who's worked on a monolith has probably run in a situation where something broke even though it wasn't technically modified. It alleviates us of those situations. It also allows you to use different technologies. So in a monolith, typically your application has to be written in a single programming language. And if you use a monolithic data store, it's usually going to be a large relational database. Whereas microservices, you can use the best tool for the job. So if you, for instance, Python tends to be very quick to develop with, but it is lower performance. So if you want, you can write your user-facing UI or API code using Python. But if there are SLAs for certain services, you can go down to Java or C++ or Go or something like that. I don't necessarily recommend different programming languages for different services. I find that it fragments the knowledge. I'm a big fan of using the correct storage technology for the job, though. So, SQL doesn't work the best for every scenario. Adding something, even adding caching layers, things like that, using an in-memory database for some things, it opens up a lot of opportunities to use the best tool for the job. And I mean, can't say that I haven't taken a job or two in response to trends. Sometimes you feel the need to learn a technology, and as such, you push to use it in your job, right? So I've seen some companies maybe push to use microservices where it's not applicable because it is, what people want to work on, and also people taking microservices jobs because they want that on their resume. Okay, so how do we go about this? There are two main options. There's a Big Bang rewrite, and there is the strangler pattern, also known as the strangler fig pattern. Big Bang rewrite. What you're essentially starting from scratch. Okay, you are rewriting your application using your learnings from your previous iterations to implement it in a different architecture. Don't do it. Full-scale rewrites are where software goes to die. There are very few examples of these rewrites working well. They usually end up, if not harming the company, wasting a lot of resources and time. As Martin Fowler said, the only thing a Big Bang rewrite guarantees is a Big Bang. So I would never recommend a complete rewrite. You have a bunch of battle-tested logic that you probably want to keep. So that leaves us with the strangler fig pattern. So the strangler fig pattern was created by Martin Fowler. It's named after a parasitic tree that will find a host and wrap around the host, draining it of resources, using it to serve its ends, and then eventually it dies, and the strangler fig replaces it in the forest. What the goal is to incrementally replace functionality from your monolith with a service. The granularity to which you do this with really depends on your use case. And what you can do is start by sectioning off larger sections of your monolith into larger services, and then breaking those down incrementally. But you can also break them down into very small services initially, and then if need be, you can combine them into larger services. It's all about learning and measuring. Allows you to measure and confirm correctness. So if one common thing is what they call a dark deployment. And in this case, what you do is you deploy both versions of your code simultaneously. And you may not even use the new code, but all flows run through this new code. And it allows you to check to make sure that the results of the calculations and the data in the database matches what you expect from the production service. It also allows you to discover problems as you scale. So one thing that's very difficult about microservices is communication between services. And I find that in this pattern, what you can do is you can start out with something that's a little bit more familiar. For instance, synchronous calls between your monolith and your services. And then as you grow, you're going to notice limitations. You're going to notice latency issues. And this allows you to slowly figure out where those issues are going to come from, and then gives you the opportunity to change approach. For instance, go to an asynchronous messaging model or something like that. When you go full out and do microservices from the beginning or from scratch, these problems generally don't creep up until you've already invested a lot of time and money into your system. So at least this way, you'll see these problems come on more slowly, and you'll be able to adapt to them at your own pace. Okay, so I'm going to go through an example of a strangler fig pattern of how you would potentially break a larger monolithic system down into a service-based architecture on its way to microservices. Okay, so we're going to start with the invoices section of your application. So this is one business unit, represents a kind of vertical within your business, and it's a very cohesive unit. So what we're going to start is by creating our own UI for invoices. Okay, and we're going to link it into the API that already exists in your monolith. Then what we do is we take the logic out of the monolith, or correction, we copy the logic from the monolithic API, and we create a very granular service API. Okay, this API still calls the monolith database, so it's still tied and coupled to the data structures that are in this database, but it acts very independently. Okay, and at this point, we still have this invoices logic in the monolith, so we are able to potentially compare in both terms of performance and also correctness. When we're confident that our changes are correct and we're looking to completely change and completely break this off, we break it out into its own data source, and we do communication between the logic layer of the monolith and the new service. Okay, so this can start out as, in this case, this is a kind of synchronous call. So how you communicate depends on your use case. I would start out usually with a RESTful API of sorts for the microservice, and then synchronous API calls between those services. When you're up and running, then it's time to remove that functionality from the monolith. So you've got a slightly smaller monolith, and you've got the functionality and the data store completely separated. So now we're going to keep going, and we're going to say that we're having issues with our shipping module being very, very busy. So we're going to pull our shipping out, and we're going to follow the same process. We're going to create a UI that harnesses the existing logic in the monolith. We're then going to copy out that API logic out into its own microservice API, again, using the existing database for the monolith. We then break that database out, and we can decide at this point that maybe the shipping API would be better served with a MongoDB rather than the large monolith, which uses a SQL relational database. Again, we're using something similar to synchronous API calls between them. And at this point, maybe we're starting to realize that there is a certain amount of latency that we're paying for between latency and blocking between these synchronous calls. So maybe we have to go to something with a message bus, which allows us to do asynchronous calls. So rather than the monolith reaching out to the shipping API and waiting for that response, it can send a message out and then go about its way and then get an event back. Okay, so people, it tends to be the case that people assume that these are the only two possibilities, and it's more of a continuum between a monolithic application and a microservices architecture. They are at different extremes of this continuum. So, I mean, microservices are hard, and they may not be for every organization, and there may be other ways to address the problems that your organization is facing. Okay, the drawbacks of microservices, which there are many. Okay, especially with a small company, say a startup. If you start out with microservices, you are moving very slowly. It takes a ton of time and effort to set the system up. And when it comes to a startup especially, the most important thing is to move fast, because there are tons of other companies just waiting to eat your lunch. So it's very important that you move quickly, and monoliths are a very understood pattern that allow you to get functionality out very quickly. So it's usually the best starting point. Do you have the resources and buy-in? So it takes a lot of developers to run a proper microservices architecture. It takes a lot of internal knowledge that you may not have, and it requires a lot of buy-in from management, from ownership, depending on your organization structure. So you want to make sure that all the stakeholders are aware of the investment that is required, and this includes things like additional monitoring, on-call rotations, things like that. Do you want to replace one very large problem with many, many small problems? Monoliths, because they're monitored by a single person or a small group of people, tend to be easier to keep up and things like that. Whereas if you've got dozens or hundreds of microservices up, people have to monitor those. And when you've got that many services, things fail all the time. So it's a constant struggle to keep things running and to make sure that we're diagnosing problems. And in a distributed system, everything is 100 times harder. Considerations. Do you need to move more quickly? You may not. There are plenty of organizations and plenty of units within organizations that don't, on the safety and speed scale, are much more attuned to the safety side. If you work at a bank, or even if you work on back office systems, if you don't have to get the latest feature out to your customers as soon as possible, speed is one of the main advantages of microservices. You can iterate very quickly, deploy those changes very quickly, and if you don't need that, it may not be worth the investment. Latency and failure rates. When you work with a distributed system, you get a lot of failure. You get a lot of failure within systems like crashing. You also get failure with messaging between services. There's just a lot of failure to deal with, and latency tends to fan out. So if you call a service, which then needs to call a service, which then needs to call a service, this latency accumulates. So those designs have to be considered. And again, this may not be right for your organization. You may wish to have lower latency using a very synchronous solution. You also, oh wow, that's a typo. You lose the ability to perform transactions, joins, and even logging and tracing become a nightmare. It's, like I said, everything becomes a lot harder in a distributed system. There are solutions for distributed transactions, but they're not nearly as good as a native transaction system that's atomic. Joins, when you separate your data out into multiple disparate services, you lose the ability to join in a database, or you have to sync data between different services in order to be able to join data correctly. Also requires, as I mentioned before, a large team. If you've got 1,000 microservices, there's no way that you can do that with a team of 5 or 10 developers. typically a microservice is owned by a team of 2 to 5 developers. So if you've got many services, you have to consider the fact that you need many developers, and also you need additional infrastructure, right? So you need some more DevOps people. You need more ops people, making sure that the network is up and running. It's a lot of investment in terms of people. So again, it really depends on your use case, but it's something that you shouldn't rush into thinking that it is going to solve all your problems, because it may cause more than you bargained for. So the question is, do you want this in your life, right? It may be the best solution for you, but this is kind of representative of what your life looks like when you run a microservices architecture. So some alternatives. This is the modular monolith structure. So what it allows you to do is you break your API layer or even your presentation layer into separate libraries that can be developed independently of each other. What that allows you to do is have different teams focus just on different parts of functionality. It allows you to reduce coupling, at least from an implementation perspective. It allows you to reduce the dependencies between these different libraries. What it doesn't do is relieve you of the deployment coupling. So this would still have to be deployed as one single unit, but you could package these sections up as, if you're in .NET, a NuGet package, or if you're in Node.js land, as an NPM package. So it allows you to be more modular with your development. You can go with a service-oriented architecture. It gives you many of the benefits of a microservices architecture, but allows you to keep your sanity when it comes to the number of services. You can deploy your invoicing and billing separately than your user management and make sure that changes in one don't have any effects on the other. So it's a great middle ground, and it's honestly what I would suggest in most cases. And you can adjust the granularity and the size of your services as you go along and you learn more about your system. Because at the end of the day, that's kind of what software architecture is about. It's about building a system and then measuring and then determining where the weak points are or what you need to do to improve things in terms of performance and reliability, and then making modifications in response to that. Making too many architectural decisions ahead of time, usually many of your assumptions are invalidated and you end up wasting some time on parts of an architecture that won't work. The real question you should be asking is, what are you trying to accomplish, right? Are you trying to accomplish smoother deploys so that you can deploy more regularly and add value to your application on a regular basis? Maybe something like a service-oriented architecture will get you there. If you're looking for more robustness, maybe you need to focus on your monolith and break it out into a modular monolith. Microservices, the best quote that describes what microservices is, it buys you options, but those options come at a cost. So it's important to recognize that there are trade-offs and that this is not the solution to all of your problems. The main resources that I used for this presentation were 2 books by Sam Newman, who is a microservices and serverless expert. He's got a couple books. One very applicable to this talk is his new Monolith to Microservices book, which I've read. It's quite short. It's under 300 pages, and it's fantastic. It goes into a lot more detail about implementation of the strangler pattern and things like branch by abstraction. I highly recommend both books. and also martinfowler.com. So Martin Fowler has developed a lot of the patterns when it comes to service-oriented architecture and microservices, as well as many other things. He's got a few great books, refactoring among them, and I highly recommend that you check out his blog as well as some of his books. And questions?
Okay, thank you very much. If anybody has questions, toss them in the chat. I'm just going to be going from the top. Okay, with loose coupling, how do you ensure that all microservices are not running out of sync when uncompatible versions of microservices are deployed?
That's a very good question. So generally what you want to do is you want to add to an interface and not change in an interface, right? So if you've got different services relying on V1 of the billing service, you don't want to change the billing services interface because it will break anything that's trying to use it. So what you would want to do is version that microservice. So you would add a new API, say get bills. You want to change the way that the payload is structured. So what you would do is you would usually add a newer version of that API endpoint and allow older services to consume the older version and newer services to build upon the newer version. You can do this within the same service, or you can create a versioned service as well. I recommend the first unless you see a reason to break the services out. But generally, API versioning is how you would accomplish that.
Perfect. Hope that answered your question, Boris. Okay. How do you make sure services are properly talking to each other when needed, if they are distributed?
So generally speaking, what you want to do is you want to use some sort of messaging system, and you want to use a combination of tracing and logging to make sure that things are going through the system, and the whole time you're monitoring the different parts of your system. So if you see that messages are being dropped, or that all of a sudden a service is not getting any messages, or getting a largely reduced load of messages, then you would look into it using distributed logging to trace things. Yeah, I hope that answers the question.
All right. If you have any follow-ups, you can just put it on the chat, Sanket. Can you clarify how many developers are needed? This is in terms of the microservices architecture at a startup.
It really depends. You can have one developer managing a dozen services, or you can have 2 or 5 developers managing a single service. It really depends on things like the size of the service, how often the service changes. If you've got something, for instance, your auth that never changes, I mean, you can add it to the on-call rotation, but you don't really need developers to actively work on it. You need that knowledge there, but it's not really something that you need a team to be dedicated to. So it really depends on the amount of change and the size of the service, but there's no one-size-fits-all solution.
Perfect. She says, thank you, I understand. Okay, how do you ensure that chain of responsibility can be implemented in microservices, and how to design fallbacks when the components fail?
Sure. So basically, you don't. How can I put this? You should be expecting failure in a distributed system. So it's not so much that you're designing failbacks; it's that fallbacks. It's that you are designing your UI to expect to potentially not have data, or to have things time out. And also the key is to react to failure appropriately. So whether that's with correct monitoring, or even something as simple or as advanced, I should say, as the circuit breaker pattern, which allows you um, to quickly fail if a service stops responding. What that allows you to do is, instead of waiting for 3 or 4 different chain timeouts to fail quickly and then reinstitute that service when it's back up and running. But basically, what you want to do is you want to, in the case of handling a chain of services relying on each other, you want to expect failure and design your system such that failure doesn't mean that the application doesn't work. You want to use like a graceful degradation of service.
Perfect. Does each service represent an API in monolith pattern? How are servers, in quotes, running in microservices?
Can you repeat that? Sorry.
Of course. Does each service represent an API in monolith pattern? How are the servers running in microservices?
Sure. So how the services run really depends. I mean, nowadays it's all serverless, managed by Kubernetes. Typically, you're going to want these services to be running on their own, within their own sandbox. So whether it's containers or their own like bare metal servers. As for can you repeat the first part of the question? Sorry, the 2 parts are very different, so I'm trying to answer both of them.
Okay, so does each service represent an API in monolith pattern?
Thank you. Yeah, so generally speaking, the API in a microservice just represents the surface area. So it represents what it can do in response to requests, right? So typically what you're trying to do is you're trying to replace that service area within the monolith with the functionality of the microservice. I think that answers your question. If not, please clarify in the chat.
Eric, do you want to give a thumbs up if that answers your question? And I think he's still chatting. Yep, he's good. All right. Can you recommend any certifications for microservices?
No. Microservices is fairly new, and there's still some debate as to what qualifies as a microservice. Whether something that has 10 API endpoints is a microservice. It's too new. I know Sam Newman has a great training video on O'Reilly Learning. I am not familiar with any microservices certifications at the moment. And I don't think we'll see anything for the next year or two until we really get a sense of what this architecture means. There's still too much variance in what people use to describe microservices.
Okay. And how does the scalability work out if 3 or more instances of the same service is talking to the same database?
That is a very good question. So kind of the same way that you would do that with a monolithic application, right? So you can start by scaling out the API nodes. So say you've got a user service, and you start it with one API node and one database node. You can scale out those API nodes to say 4 or 5. And then at some point, you're going to run into database contention issues where you've got too many services competing for reads and writes on those databases. On that one database. So at that point, you can do things like replication, like read-write replication, or sharding, but these are things that you would typically do in a monolith as well. You would scale out the monolith code, and then if you're dealing with database issues, you would shard, or you would do replication and split reads and writes out and things like that. So the same solutions would apply to a microservices architecture.
All right. Does anyone else have any questions? That's the last one on the chat. Okay. I think that's it. Thank you so much, Huey.